Okay, good morning, everybody. So today we are going to learn, we're going to continue working with the radical. And what we're going to learn is how to simplify a radical expression. This will be very important for future dates. So today we're just simplifying, but then we're going to learn how to multiply, how to divide, how to add, how to subtract. So today is very fundamental in understanding uh, everything in radicals. So let's start off with the first type of problem. Um, so the first type of problem I want to show you are radicals that when you take the square root or you take the fifth root, you get a whole number. Those are actually pretty easy. Okay, you could really just type that in your calculator. And so remember, n right here, that's what we call our index. And remember, you're going to take, you're going to divide your exponent by the index. Now these don't have exponents. Well, it has an exponent of 1. But on a problem like this, you could type in your calculator. A problem like this, you could type in your calculator. And I'll show you that here now. So I'm going to type both of those in the calculator. So the first one we had was the square root of 46656. And as you can see on the far right, that's 216. What does that mean? That means 216 times 216 is 46,656. So on the first problem, that equals 216. The next problem, I'm supposed to take the fifth root. Now you may see down here this nth root one. So you're going to hit that. You're going to type 5 as the index. Remember, if there is no index, it is automatically assumed and calculated to be a 2. But this one has a 5, and we're doing the fifth root of 1,889,568. Notice that's 18. What that means is if I take 18 times 18 times 18 times 18 times 18 5 times, I get back my number. Okay, so the first two problems, those are the two answers. So I wrote those on our page. Okay, the fifth root of 1,889,568 is 18. The square root of 46656 is 216. So those are pretty easy. Now let's throw in some variables. And what we're going to do is we're going to remember that you always divide the exponent by the index. So these really are not so bad. 3 goes into 9 evenly. And so remember, this actually equals z to the 9/3. We learned that last class period. But 9 divided by 3, well, that's 3. Okay, 6 divided by 2, so that would be m over 6 over 2. 6 divided by 2 is 3. And notice there's no radical left because I simplified. Here, negative on the outside, that'd be n to the 10 over 5. And 10 divided by 5 is 2. Okay, so when you're turning this in, if you want to skip this step, that's fine. 9 divided by 3 is 3. 6 divided by 2 is 3. 10 divided by 5 is 2. Okay, so I'll let you try. Actually, we'll go ahead and do these together. So the 6th root of 64, you're going to type that in the calculator. Third root, cubed root of 729. Type that in the calculator. We haven't done one with 3 variables, so I'll show this one. What we're going to do is we're going to take the exponent divided by the index. So we're going to take 2 divided by 2, that's 1. 4 divided by 2, that's 2. 10 divided by 2, that's 5. You may be thinking, wait, what happens when this is not divisible by 2? So like, what if this was an 11? And I'm going to show you what you do here on another page. Here, just take all the exponents divided by 7. 21 divided by 7 is 3. And 42 divided by 7 is 6. So that is how you simplify radicals, the easy type. However, not all radicals are perfect squares. And so if we type, say, square root of 8 in our calculator, this is what it spits out. Notice it's irrational. And I don't think you want to write down this whole number because it goes on forever. It's impossible. So you would have to round. And so 8, a number like 8, I need to show you how to simplify it. Okay, so you will never type out a decimal. Okay. Some rules with multiplication. If you have 2 numbers inside of a radical, you could separate those into the same radical through the operator of multiplication. And that works for any index. Okay. And then we already talked about this. 2 divided by 2 is 1. Okay. But here's an example. If you type in square root of 45 in your calculator, it's going to be a decimal. So what you're going to do instead is you're going to think, how can I break 45 up? Okay, so if we think about, and these are all squares, so I'm going to write down the squares on the side. 1 squared is 1. 2 squared is 4. 3 squared is 9. See, these are what we call perfect squares. And I'm only looking at squares because these are all index 2. 4 squared is 16. 5 squared is 25. 6 squared, 36. 7 squared, 49. And so when I think about 45, what's the largest number that divides into 45? 49 is bigger than 49. That doesn't work. 36 does not divide into 45. 25 does not divide into 45. 16, you take 45 divided by 16, you get 2.8 in sum, so not 16. 45 divided by 9, yeah, that's 5. So we're going to write this as the square root of 9 times 5. But just like up here, we said if you have a product, you could break it up into the 2 radicals with the operator of multiplication. So I could break this up into the square root of 9 times square root of 5. And we know square root of 9 is 3. So this simplifies to 3 square root of 5. So when you're simplifying, your goal is to take this number and make it smaller. Okay. Square root of 8, the biggest number that goes into 8 without going over is 4. So I'd say square root of 4 times 2. And then I could break it up into the 2 square roots. That's square root of 4 times square root of 2. But we know square root of 4 is 2. So that simplifies to 2 square root of 2. Now, if you're never unsure and they're whole numbers, you can always type it in your calculator without the x's, of course. And you can see that the square root of 8 is 2.828. And the 2 square root of 2 is should also be 2.828. So that's one way you can check your work when your answer is a number. 48, let's see, 49 is too big, 36 doesn't go into 48, 25 doesn't go into 48, 16 does. So that equals square root of 16 times 3. And I usually skip this step. And I say square root of 16 is 4. And you didn't do anything to the 3, so it stays inside. Okay. 150. 150 is a little bit harder to think of. So one thing I have always done when I get to large numbers is I'll write the number and I'll start breaking it down. So I think of 150. 150 is 15 times 10. And then 15 is 5 times 3. But 10 is 5 times 2. So when I look at this, if I see any numbers more than once, then that must be the factor. So see how 5 times 5 is 25? So I know that the largest number that goes into this is 25. So I'm going to write this as square root of 25. 25, 50, 75, 100, 25, 50, that'd be 6 times. But the square root of 25 is 5. Okay. Same thing here, 1350. Let's see. I know it's divisible by 5. If I take 1350 divided by 5, that's 270. And then if I could take 270 divided by 5 again, that's 54. And then I can take 54 divided by 3, that's 6 and 18. And that's 3 and 2. That's 6 and 3. I'm running out of room. What I'm trying to get at, and then the 6 makes 3 and 2. And so if you were to take 1350 and break it up, you'd get 5, 5. You'd get a 3 and a 2. And then you could break 6 into 2 times 3. I just ran out of room. And then you have a 3. So what we're doing is we're looking for pairs of numbers. So I have 5 times 5 is 25. Times 4 is 100. Times 9 is 900. Well, that's not right. Somewhere I messed up. Hold on. I did 5 times 270. 5 times 54. Put down my 2 5s. 6 times 18. Where did I get 18? 6 times 18 is not 54. Wow. Six times 9. And that breaks into 3 and 3. So I should have 5, 5, 3, 2, and then 3, 3. So I just need to get rid of a 2. Now it's easy to see because I have 25 times 9. That must be the number it breaks into. So this equals to the square root of 225 times 6. And the square root of 225 is 15. Now, in case I lost you, what I did As I said, 1350 is 5 times 5 times 3 times 3 times 3. And then I saw that this is 25, and that's 9, and 25 times 9 is 225. I'll show you an easier way here in a little bit. All right, so probably there's two ways to do these problems. One is you just think, okay, that's 36 times 2. And that's probably the easiest way on problems like these. And then the square root of 36 is 6. You could also, and this is probably the harder way, is you take 72 and you break it up into the prime factors, like that's even. So that's 2, 72 divided by 2, 36. And then 36 is 6 times 6. 6 is 2 times 3. 6 is 2 times 3. And probably the better way to show you is you only look at the ends of your factors. So you only look at the 2, the 2, the 3, the 2, and the 3. Now, what do you have in common? You have 1, 2. You have 1, 2, 1, 3. 2 times 3 is 6 with the 2 left over. Okay. The cube root is 750. Um, 750, I know 5 goes into that. Actually, I know 10 goes into that. That's 10 times 75. 10 is 2 times 5. 75 is 25 times 3. And 25 is 5 times 5. What you're trying to do, and I'm not going to circle this time, so I think that made it confusing. You have a 2, a 5, a 5, a 5, and a 3. And you're looking for a set of 3. And you do have a set of 3. You have 1, 2, 3 5s. That'd be 125. The cubed root of 125 is 5. Now, anything you did not circle will stay inside. So you did not circle the 2. The 25 was broken down. You did not circle the 3. So what's left is 2 times 3, 6. Another one, 75. I would probably just recognize that this is 25 times 3. And square root of 25 is 5. Here, I might break up. See, 200. 200 is 20 times 10. 10 is 5 times 2. What I'm trying to do is I'm trying to make prime factors where I have 3 of them. 20 is 5 times 4. And 4 is 2 times 2. So 200 equals 5 times 2 times 2 times 5 times 2. Now you may notice that I said 2 3 times. So I'm going to circle my 2's. Now, if this index was a 4, you would need to have 4 2's. If this index was a 5, you would need to have 5 2's. Okay, so I have 3 2's. So the cube root of 8, 2 times 2 times 2 is 2. And then what's left over? 5 times 5, 25. Now, what do you do when, and it's the same step, when you have a radical with a coefficient out front? So notice all of these have numbers out front. And they're the same thing, but whatever you bring out, you multiply it by the number outside. Okay. So here, 600. I could probably do that one without doing the tree. 600 is 100 times 6. But square root of 100, we'll break this into 2 square roots. But the square root of 100 is 10. And negative 8 times 10, negative 80. Okay, so sometimes I like to go from this step to this step. Square root of 100 is 10. Negative 8 times 10 is negative 80 with the 6 left over. Here, negative 96. I can't think of the biggest thing to the 5th power that goes in the negative 96. I'm going to break that up. Let's see, 96 is even. You know, I'm going to guess it's 2 without even doing it, because let's see, that's 2 to the 5th power. What's 2? Yeah, 2 to the 5th power is 32. 2 times 2 times 2 times 2 times 2 is 32. So I'm going to write this as the cube root. There's 3, sorry, not cube root, 5th root of negative 32 times, let's see, that'd be negative 32 times 3 is negative 96. And then I could break it up into 2 cube roots. Why do I keep saying cube? 5th roots. And 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. We want negative 32. So we're going to do negative 2, because negative times negative is positive. If you do negative times negative an odd amount of times, which is 5, you get a negative back. So the 5th root of negative 32 is negative 2. So this is 3 times negative 2, which is negative 6, with the 5th root of 3 left over. Yeah, I'll let you try the other 2 yourself on your own. We have one more thing. What do you do when the exponent is not divisible by the index? Notice 13 is not divisible by 4. 23 is not divisible by 4. Probably what I think the easiest way is to break these up into numbers that are divisible by 4. So for example, we'll do the A's. If I'm counting by 4s and I'm trying to get to 13, we go 4, 8, 12. So 12 is the closest number to 13 without going over. I'm going to break this into 8 to the 12th with an A. Excuse me. And notice when you multiply and you have the same base, you add the exponent. 12 plus 1 is 13. If I count by 4s, trying to get to 23 without going over, 4, 8, 12, 16, 20, 24. 24 goes over. So I'm going to write this as 20. B to the 20 with 3 left over. When I do C to the 10 and I count by 4s, 4, 8, and then after that it goes over. So I'm going to break this into C to the 8, C squared. And then when I break D trying to count by fours. If the exponent is smaller than the index, which it is, there's nothing you can do with it. So we're just going to leave that as d cubed. Now what I'm going to do is I'm going to take a squared divided by 4. 12 divided by 4 is 3, so that goes out here. And I'm going to take 20 divided by 4. That's 5. That goes out here. I'm going to take 8 divided by 4. That's 2. And nothing else is divisible by 4. And so what's left over just stays as in the radical. We call that the radicand. So what stays inside is the a, the b cubed, the c squared, and the d cubed. One way to check your answer is to make sure all the exponents 1, 3, 2, 3 are all less than the index, and they are. Okay. Now here, same type of problem. The only thing is they added in a number. So let's think about the square root of 125. That's probably 25. So I could break this up into the square root. I believe 25 is the biggest square. Yes. So 125, we'll say that's 25 times 5. Now, x to the 4th is divisible by 2, so we'll leave that alone. Y is 1. 1 is less than 2, so we'll leave that alone. 5 is not divisible by 2. So if I count by 2s, that'd be 2, 4. So I break that up into z to the 4th z. And then I simplify what I can. Square root of 25 is 5. It goes on the outside. I took the square root. The exponent of 4 divided by 2 is 2, x squared. And then 4 divided by 2 is z squared. And then you write down what's left over. You did nothing with the 5. You did nothing with the y. You did nothing with the z. Okay, so that is how you simplify. Okay. I don't have time to do every example, but notice all of these have the index of 2. I think I have time for one more. Actually, we have time. We have time to finish. So real fast, when you get the hang of these after a while, 6 is divisible by 2, so you leave it alone. 5 is not divisible by 2. Count by 2s, you get 2, 4. So we're going to break that into 4 and 1. This is divisible by 2, comes out. 6 divided by 2 is x to the 3rd. 4 divided by 2 is 2, comes out, y squared. The y stays inside. Here, 18. I could break that into 9 times 2. X to the 4. 4 is divisible by 2. Let's leave it alone. 6 is divisible by 2. Let's leave that alone. 10 is divisible by 2. Let's leave that alone. And then I start working. That's square root of 9 is 3. So you bring out a 3, and you already have a negative 5. Negative 5 times 3 is negative 15. And then 4 divided by 2. 6 divided by 2, and 10 divided by 2. What's left over? Just the 2. Okay. Now, before you get into a habit of doing these, it is not always 2. Remember, we just did an example. I thought we did an example. The first one, the index is what it must be divided by. So on your practice on the next page, and no, I don't expect you to do all of these. I circled the ones I wanted you to do in the practice, but pay attention to the index. Like this is a 4, that's a 5, that's a 3, that's a 3, that's a 3, because it means you're looking for different sets. Other than that, I hope you are prepared to learn or how to, hope you know how to simplify a radical expression, and I'll see you next time. Bye-bye.